Good morning. How is everybody this morning? Good, good. If the water treatment rapid improvement event people can come up to the front, we'll get started. I brought this team together for my rapid improvement event. I was the facilitator, also the process owner, but Ray Horswell was the process owner during the event. So I tried to stay out of the whole discussion and let the team come up with what's best for Denver Water as far as efficiency in how to do things and all the decisions that have been made. So with that, it's the team photo from left to right. Justin Pyle, David Clark in the back, Terry Ranker, Ray Horswell, Ed Rubenstein, Nick Yaris, Steve Holder, and Patty Wellborn. Special thanks to Steve Smith, which is a water treatment operator out at Marston. He helped us out with some visual aids, agreeing that what was easy to see, what wasn't easy to see. So we had an actual operator confirm that we were doing something right in the event. Also, Nicole Ponsolette, Mary Price, David Swedinsky, Rob Richmeyer, Zach Alabassi, Andrea Song, Austin Steckler, and anyone that we may have missed. There was a lot of great feedback at the report outs every night that kind of helped us steer the way to how we made the decisions that we made. Reason for action, there was no defined asset management system between water treatment and the ICE group. Our scope originally was 16. We actually knocked one off because there was one particular analyzer that had 4 of the same analyzers that were just all on one board, controlled on one board. So we knocked it down to 15. The aim was to establish an asset management total productive maintenance system between the water treatment plants and ICE group. With that, I'll hand it over to Ray Horswell.
As Justin was saying, we're looking at 15 types of analyzers. This isn't the amount of analyzers. There's many analyzers throughout the plant, but we're looking at the online process analyzers, the chlorines, which we have different types, temperature, pH, turbidity, ammonium monochloramine, conductivity, NTEC sensors that are in the filters. Take a look at bed expansion and turbidity, dissolved oxygen probes, and streaming current monitors, which are at Moffett now and probably soon to come to a plant near you. So,
So the first thing we did is map out the current state process, and we basically took all the analyzers, lined them up across the top, and went through their frequency as well as the actual procedure that's done on each one. And this is for each plant, so it highlighted where we were standard, where we weren't standard, what was being done at one plant, what wasn't being done at the other plant for the same thing. We also quantified the difficulty of each PM, so we had a good idea of just how much time and effort it took to do each one. At the end, we kind of used this as well to do our target state, our final state, and standardized across the board. So what one tech is doing at one plant for the same analyzer, they're doing at the other plants as well. Next one. And this is our map of our current state, the right brain exercise, trying to determine visually, get a picture of what's going on in the field. And you can see in this top left picture, well, basically at the very top, we recognized there was kind of a long ways to go. It wasn't going to just happen overnight. In the top right, you have a ICE technician with his hair on fire, and he's running around in circles, not sure what to do, just kind of tackling, putting out fires as they come up. The bottom one is kind of the the tug of war between operations and ICE. ICE, they're scheduling their work, they're coming out to the plant to do certain things, and then something comes up and plant says, hey, we need to change your priorities and we need you to do this. So this is helping visualize this. And then the top right there is basically we have some equipment that's just flat out neglected. It's not used, it's not utilized by plant, it's not maintained by ICE, and we'd like to rectify that.
And then to go along with that, we did at Gemba. We went out and followed Dave around to certain analyzers. We went straight to one. He goes out and does a round, but we calculated how long it takes him just to get to one analyzer, how many feet it takes to get there, and if we could improve upon that and reduce time and reduce distance, and work through what he does and how long it takes him to do it on a standard analyzer at Marston. Our target state was to get everybody on the same page, everything copacetic, get a standardization for PMs, documentation, procedures, schedules, and analyzers, and have defined parties. So in the picture, you have standard SOP, and those are being written, and those should be done by the end of the month. Who's doing what, and positive information on what you're doing, when you're doing it, how to do it, and where to do it.
So with that, as Terry alluded to, so we came up with our future state here with our 15 analyzers. You can't really see everything that we came up with on this clearly from there, but it was really quite a bit. Is what needs to be done, how long does it take, what does it make the most sense of who's doing it, when and where. So we came through and came up with that. This also is established or will establish our standard work in our future state. Then one of our metrics was total productive maintenance, and the general quick synopsis of that is visual management. What's the easiest way to go up and see if something's good or bad? How can we make that a visual management system so that whoever is working through it, the operator, the ICE technician, whoever it is, to do just that, make the most simplest, easy, quick visual management on the different analyzers.
So we were looked at developing standard work. We were able to complete the standard work for the 720Es and identify some of the analyzers that don't have standard work yet. Luckily for us, we were able to pull some of the work from that Kevin had already created to build these, so that was a nice break. And then we also identified several safety improvements, including safety glasses, maybe a light for the technicians when they're down in the gallery so that they're better able to see what they're doing. The ability to hang the probes so that they're not dangling, so they're not pulling wires or causing electrical risks. And then the normal gloves, safety glasses, trip and fall. The best one, traveling. We reduced the traveling significantly.
And then to go along with the TPM, we went out and we made the analyzers able to be read by anyone. If you have a rotometer on it, you have red. Red is outside normal. Green is where it needs to be. And then you have a range. If it's in the green and it's outside of the range, then if it's outside of the green on the rotometer, the plant technicians can adjust it, no problem. But then once it's in the green and the analyzer is still reading off on the span, then we can go grab an ICE tech and they can rectify the situation. Also with the Chemtrax, we learned that they turn red, but also at the same time, it might be red, but why is it red? Then we threw a label on it. We actually took the tape off and put a more official label on them. And you can see the span and where it needs to be, and if it's out, then either adjust flow or go grab an ICE tech. Same with the turbidimeters. Before, it could have been anywhere, and right now this plant's offline, so it might be a little out of spec because there's no water running through them. But you could walk up to any turbidimeter at any point in the process, and it's got a span on it. Okay, it's below 10, it's good.
Okay, so some of my target metrics for this rapid improvement event, safety improvements, targeted 6. Patty went through them with safety glasses, the travel, proper handling of the instrumentation when they're doing maintenance on them. Total productive maintenance program, targeted 100%. We only set up the TPM program for Marston, so that's 1 out of 4 treatment plants, which is 25%. Write or update SOPs for all the water treatment plant analyzer assets. They all have SOPs already written. We are trying to formulate the best way to write those in our new practices. We did get 4 of those done. Cycle time per week. I was targeting 25% reduction initially for the cycle time for the walk-arounds on the maintenance. It took 1,770 minutes. Out of the rapid improvement event, we reduced it by 70%, and it only took 354 minutes for cycle time. Distance traveled to perform the work per week for all 6 ice techs to go out to all 4 treatment plants was 507 miles a week. Tried to reduce that by 50%. We accomplished that, went above and beyond. It reduced it to 80%. We reduced it to 100 miles a week, approximately. So all in all, a good week.
And here are the things we couldn't get accomplished due to the time constraints. The SOPs, I should have those all rewritten by the end of the month. The update the plant inspection checklist for TPM should be done by the end of the month. And then the TPM at the remainder of the plants should be done by the end of the following month. And here's pretty much our insights for the week. I think we stretched everybody to the limit on what we were looking to do. It wasn't nearly as cut and dried as I think everybody had imagined. But by the end of the week, pretty much everybody was exhausted and satisfied with the give and take that we had in it all. And we pretty much embraced all of Denver Water's values. I mean, we all pretty well cooperated when it didn't look like a fight scene. But we were. It was very good. I personally learned a lot about TPM, which I didn't know very much about, and we learned some things on the partnership that's going to start being included on the online analyzers. So it was, like Justin said, a pretty good week, all in all. Uh-oh, questions?
Your reduction in miles, both human miles, like walking and driving?
Yes, it was both. Nicole?
So your metrics show that you're going to see significant reductions for the ice tax. Was there any kind of quantification of how it impacts the tax treatment?
So the question is, the metrics show improvements for the ice techs. How does it impact the water treatment techs? To answer that question, what the group decided was the plant operators do a plant walkthrough check twice daily. And the things that we've decided to have them do on a daily basis, since they already do the daily walkthrough, is to visualize the flow and see if there's any alarms that they could possibly take care of on their own. There's going to be some training involved, but they're already walking that route. And with the TPM, you should be able to walk into a room and 5 seconds see if it's good or bad. So I can't say there's going to be a lot of impact to the plant staff.
Is there anything beyond just daily?
So there is on the monthly for anyone that has CL17s. CL17s is a chlorine analyzer, and we came up with, as far as a group goes, on having them clean the analyzer monthly and changing the reagents. So again, that's only at 3 out of the 4 plants. Marston doesn't currently have those.
So when you talk about walking through the plant and when the water treatment technicians find something out of range and they're writing a work order, did you guys talk about any standards about writing that? Like, what is the priority on that and how long do you want to get a technician out there? Like, is it going to be within the week? Is it affecting the schedules that we already made?
The question is, when an ice tech?
No, when water, because now we're having the water treatment tech, right? And
Right.
so when they find something that's out of the scope based on your SOPs, right, that's what
Mhm.
we're referring to, and they write up a work order for the analyzers, what's the priority on that? Is it still,
So the question is, when the water treatment operator does his walk around and he finds an issue, was there any talk of what the priority is on that analyzer? So there was talks on that. If there is a flow that needs to be adjusted during a walk around, the operator is we gave everybody the permission based on the SOP and the training that we're going to provide, that they will be able to adjust the flow. If it's an alarm that they can take care of on the screen, the flow is the problem, because 90% of the time it is. If it's out of their spec, according to the SOP, then they write a Maximo based on their plant's priority system. So the plant management will base their priority on what they think, because that's their plant.
That's really something we should standardize within water treatment as far as
I agree.
water treatment section really needs to get together and decide how we're going to do that. Some plants do look at things a little bit differently. Partnership is going to play into that as well. So we need to just have a short meeting on this is a 4, this is a 3, this is why, kind of thing.
Go ahead.
Is there a plan to do a sort of physicality assessment on these assets to help guide that for the operators? So if they look at an asset that's
Yeah, that,
priority 1 or physicality 1,
We're-
and they're writing priority 4 for it, doesn't guide very well.
So the question was there a critical assessment of analyzers in this event? No, there wasn't. It wasn't in this scope. But I believe that will probably happen in another event down the road.
So in your current state, you identified siloing as in the current state, you identified siloing as one of the problems. Do you have any sense of how much that contributed to the inefficiencies of the overall process?
So the question is, in current state, we were demonstrating that we were very siloed in the past, and did that have an effect?
How much did that impact the lack of efficiency in the current state process?
How much did it affect the inefficiency of what we do? So to answer your question, the siloed part was, as far as all the analyzers go, standardization is a big part of it. There's different types of analyzers at each plant, which that is a big issue that we need to overcome. But that wasn't in the scope of this rapid improvement event. As far as anything else, the work being done, my ICE people in this group, I didn't tell anybody, hey, what this was about and things like that, because I wanted to truly view where we were all different and what different things people were doing differently at each plant. And we were doing things different at each plant as far as maintenance on the analyzer, and we resolved that by doing the standard work. Yep, we filled that out. Absolutely. Go ahead, Josh.
Justin, how many analyzers does the average water treatment plant have, and how often are they replaced?
The question is approximately how many analyzers per plant, and how often are they replaced?
Well, I
That-
know it's anywhere from 50 to 80, and pretty much up until just recently, we've been replacing them at failure. We've been, or at when they become obsolete. We're trying to look at improving that. So.
To add to that, Josh, we're trying to get to a clean slate. Again, this wasn't part of the rapid improvement event. We're trying to standardize by doing choosing by advantage. Once we choose by advantage and find out what the right analyzer is for the application, and if we really truly need it or we don't, then we'll look at possibly going to a clean slate. And then that would be more of a, TU 5300, which is a laser turbidity meter. They run 25 years. At year 20, we can go, hey, in 5 years, we're going to need to replace this. So what's the best thing out there that's going to replace it in 5 years, so we can start planning proactively, both budgetary-wise and technology-wise. Yes, sir.
At the risk of asking a stupid question, why can't these analyzers be wired or wirelessly reporting to a single place?
So why can't the analyzers be wired or wirelessly viewed at a single place? They can be. They can be. And they are via the SCADA system. They are wired from device into a PLC system that goes to a server that can be viewed via the network, per se. So we can view these at one location if choose to be, and if people have access to that. Does that answer your question?
So why is it necessary to walk around?
Because it's a visual. Because not necessarily, if there's a flow on an analyzer that isn't there, we can currently put technology in to see that, but some analyzers don't have that. They don't have that capability to sense flow or no flow. But if some instruments, if the flow drops off and it just sits stagnant, you may not know that for 15, 20 minutes, where you could maybe possibly go out of compliance.
If I may add to that, does the analog output on the analyzer tell you what the problem is, or does it just say it has a problem? My question is, does the analog output on the analyzer tell you what the problem is, or does it just tell you there is a problem and you need to look at it?
So the analog output, where I was going with that, and we did do a trial test. We went down and shut the flow off to a turbidity meter. It did fluctuate a couple tenths, but it pretty much stayed the same reading for a long period of time. So to answer your question, it's dependent on which analyzer you're talking about. If it's chlorine, it'll go high, low. A turbidity meter, especially a 1720E, of course, because you have a bucket, right? And it fills full of bucket, and your turbidity meter's reading that bucket. And that, without any flow, there's no new water that goes in there. So it's going to keep reading that same water for a period of time until...
Right, so sitting in the control room as an operator,
That's dependent on an analyzer. That is correct, yes. Dave?
So you're talking about shifting the maintenance on the CL-17s to the plant staff. What about the reagents and all that stuff? Have you guys discussed how that's going to be managed moving forward then with that shift? Or is that something that's going to be determined?
So the question is, the reagents for the analyzers, how is that going to be managed currently? Currently, it's going to be managed by the ICE group. Right. So budgetary, the water treatment plant's budget for new assets, they budget for the asset as far as the analyzer itself. The ICE group budgets for the consumables. So currently the consumables come out of my budget. And right now, Ray is doing a rapid improvement event on just-in-time reagent delivery. And we'll get the reagents to the plants.
So moving forward, are you still going to, ICE is still taking care of all the consumables? Is that what I'm understanding?
That's yet to be determined, I think. That was not discussed in the rapid improvement event. So.
Should I just hold on that just so I want to clarify? The only maintenance in the plants, I heard you say is change the reagents. Two being, because with all the other maintenance that goes on with those analyzers, it's will be done by the ICE group, correct?
The question is changing the reagents and checking water flow is all going to be done by the operators, and ICE is going to do everything else. That is a correct statement. Nicole?
So, it seems like you guys have made some really good progress in the last week, and you got a good start. Any thoughts on how we can build on this momentum, moving forward? Maybe check on
So the question is, how can we build on what we've improved so far? So to answer that question, through continuous improvement and through eliminating touch time on the analyzers, which has reduced our cycle time and our drive time as far as ICE techs go, but to validate if we're doing our job right, and if we should continue down this path, our CMs and RMs are going to reflect if we're doing our job right, if this is working. Does that answer your question, Nicole? Okay.
Isn't there the 30, 60, 90-day kind of checking points where the team comes back and kind of updates this group on, here's what we found right afterwards, here was our metrics, here's how we worked through our work plan? Wouldn't that kind of answer some of what Nicole's, that's checking where you guys are literally going back and saying, did we get it right? Do we need to revisit this piece, that kind of thing?
Yes. So the question is there a 30, 60, 90 check-in to bring back to the Denver Water team if this rapid improvement event is working? And that is a correct answer, yes. Any more questions? Thank you.